Hello there, and welcome to the Scientist Sleepy. Have you ever wondered what lies in the deepest, darkest corners of our planet, in places where sunlight has never, ever touched? Tonight, we embark on a gentle exploration into the Midnight Zone, a realm of profound mystery and astonishing life, a place that challenges our very understanding of existence. So, if you will, allow yourself to settle in, to find a comfortable position, to let your body begin to soften. And if you feel inclined, a gentle touch to the like button and a soft click to subscribe will help us continue to bring these quiet wonders to you, ensuring you don't miss out on future journeys into the extraordinary. And as you listen, perhaps you might consider sharing a thought in the comments below, a question that stirs within you, or a feeling that arises as we explore these depths. For in sharing, we connect, much like the unseen currents of the ocean itself. Let us now descend into the quiet embrace of the deep. The abyss holds secrets older than mountains. Beneath the sunlit surface, where light has never once touched, lies a realm so ancient, so profound, that its secrets stretch back to the very dawn of our planet's existence. The abyss, the midnight zone of our oceans, is not merely a collection of deep trenches and dark waters. It is a living archive, a repository of geological and biological history that dwarfs the timescales of terrestrial mountains. While mountains rise and erode over millions of years, the processes and life forms of the abyss have been shaped by forces and conditions that have persisted for far, far longer. Imagine the immense pressure, a constant, crushing embrace that has sculpted the very evolution of its inhabitants. These creatures, adapted over eons to a world of perpetual darkness and extreme conditions, carry within their genetic code the whispers of ancient oceans, of a time when life first began to explore the possibilities of existence in these profound depths. The very rocks and sediments that form the abyssal plains are themselves layers of time, compressed and preserved, telling a story of sedimentation, volcanic activity, and the slow, inexorable march of geological change that predates even the oldest mountain ranges on land. Consider the sheer immensity of time involved. Mountains, grand as they are fleeting geological features in the grand cosmic sweep. The deep ocean, however, represents a relatively stable environment that has existed, in its fundamental form, for billions of years. It is here, in this seemingly desolate expanse, that we find evidence of life's earliest experiments, of organisms that survived and thrived through periods of planetary upheaval that would have rendered the surface world uninhabitable. The chemistry of the deep ocean, the mineral composition of its floor, and the genetic makeup of its most ancient inhabitants all serve as direct windows into our planet's primordial past. This is a realm where time itself seems to flow differently, where the slow, patient processes of evolution and geology have been allowed to unfold undisturbed by the more dynamic, and often destructive, forces of the surface. The secrets held within these depths are not just about the present, but about the origins of life, the formation of our planet, and the enduring power of adaptation in the face of unimaginable challenges. It is a place where we can contemplate the truly ancient, a perspective that can, in its own way, be deeply calming, reminding us of our place within a much larger and much older cosmic narrative. In the crushing silence of the deep, life's ancient tales, etched in time, whisper of origins far older than any peak that kisses the sky. Life thrives where we imagine only death. It might seem, at first glance, that the profound depths of our planet's oceans, particularly the realm we call the Midnight Zone, would be a place utterly devoid of life. A silent, black expanse where the crushing pressure and eternal darkness render any possibility of existence an impossibility. We often associate the absence of sunlight with the absence of life, a natural, almost intuitive assumption rooted in our terrestrial experience. After all, on the surface, sunlight is the fundamental driver of nearly all ecosystems. Photosynthesis, the process by which plants and algae convert light energy into chemical energy, forms the base of most food webs. Without that initial spark of solar energy, how could anything possibly endure, let alone flourish? This perception, however, is a beautiful, yet ultimately incomplete, understanding of life's extraordinary tenacity. The reality of the deep ocean is a testament to the boundless creativity of evolution, demonstrating that life, in its most fundamental forms, can find a way to persist, adapt, and even thrive in conditions that we, from our sun-drenched perspective, would readily deem uninhabitable. Imagine an environment where the weight of miles of water presses down with unimaginable force, where temperatures hover just above freezing, and where the only light is the ephemeral glow of living organisms themselves. It is a world that challenges our very definition of what life requires, pushing the boundaries of our scientific comprehension and revealing a universe of biological innovation hidden beneath the waves. The creatures that call this place home are not merely surviving. They have evolved intricate and astonishing adaptations that allow them to not only endure but to flourish, creating complex and vibrant ecosystems in a realm that, to our superficial understanding, appears to be the very embodiment of death. This paradox, the thriving existence in a place we perceive as lifeless, is one of the most profound revelations of deep-sea exploration, urging us to reconsider our anthropocentric views of habitability and to marvel at the resilience of biological processes. The Midnight Zone, far from being a void, is a vibrant testament to life's unyielding spirit, a place where the absence of one fundamental element, sunlight, has spurred the evolution of entirely new ways of living, proving that where we imagine only death, life has found a way to bloom in the most unexpected and magnificent forms. This is not a place of decay and stillness, but a dynamic arena of survival, adaptation, and quiet, persistent growth, a living testament to the universe's capacity for wonder. In the profound absence of sunlight, life in the Midnight Zone has found entirely new foundational pillars upon which to build its existence. This is where our terrestrial intuitions about habitability begin to falter, and where the true marvel of biological adaptation comes into sharp focus. The conventional understanding of life is intrinsically linked to the sun's energy, powering photosynthesis, the process that underpins most of the food chains we are familiar with. However, in the perpetual darkness of the deep ocean, this primary energy source is entirely absent. Yet, life not only persists but thrives, creating intricate ecosystems that are as complex and diverse as any on land. This is achieved through a remarkable process known as chemosynthesis. Instead of relying on light, deep-sea organisms, particularly specialized bacteria and archaea, harness chemical energy from inorganic compounds released from the Earth's interior. These compounds, such as hydrogen sulfide, methane, and ammonia, are abundant in certain deep-sea environments, notably around hydrothermal vents. These vents, often referred to as black smokers or white smokers, spew superheated, mineral-rich water from beneath the Earth's crust. Here, chemosynthetic microbes form the base of a unique food web. They convert these chemicals into organic matter, providing sustenance for a host of other organisms that have evolved to live in symbiosis with them or to graze upon them. This means that entire communities, from microscopic bacteria to larger invertebrates like tubeworms, mussels, and shrimp, can flourish in complete darkness, powered by the Earth's internal chemistry rather than the distant sun. The giant tubeworms, for instance, found near hydrothermal vents, have no mouth or digestive system. Instead, they host symbiotic chemosynthetic bacteria within their bodies. The worms absorb hydrogen sulfide and other chemicals from the vent fluid, providing them to their internal bacteria, which then produce organic compounds that nourish the worm. This is a profound example of life creating its own sustenance in an environment we would consider utterly barren. Beyond the vents, the concept of marine snow also plays a crucial role. This is the continuous shower of organic matter, dead plankton, fecal pellets, and other detritus that drifts down from the upper, sunlit layers of the ocean. While this may seem like mere waste to us, it represents a vital food source for many deep-sea creatures. Scavengers and detritivores have evolved specialized adaptations to efficiently collect and process this falling organic material, effectively creating a food chain that, while indirectly linked to sunlight, is entirely sustained by the processes occurring in the deep. The sheer variety of life forms that have adapted to these conditions is astounding. We find fish with specialized sensory organs to detect prey in the dark, crustaceans with bioluminescent capabilities, and invertebrates that can withstand immense pressures and extreme temperature fluctuations. The ability of life to find a foothold, to develop novel metabolic pathways, and to build complex ecological relationships in the absence of light and under immense pressure is a powerful illustration of evolution's boundless capacity for innovation. It forces us to expand our definition of a habitable environment and to recognize that life's fundamental requirements are far more flexible and robust than we might initially presume. The midnight zone, therefore, is not a graveyard of the ocean, but a vibrant, albeit alien, garden, cultivated by chemical energy and the detritus of the world above, demonstrating that life's purpose is not merely to survive, but to adapt and to flourish in every conceivable niche. Where we perceive only the stark finality of death, life has woven a tapestry of existence, powered by the very pulse of the planet. The midnight zone is not empty, but inhabited. For so long, humanity envisioned the deepest parts of our oceans as desolate voids, silent expanses devoid of life, or perhaps populated by only the most rudimentary spectral forms. This perception, born from a lack of direct observation and a natural human tendency to project our own experiences onto the unknown, painted a picture of an utterly barren realm. However, as our technological capabilities have advanced, allowing us to peer into these crushing depths with increasing clarity, that perception has been profoundly, beautifully overturned. The midnight zone, far from being a lifeless desert, is in fact a vibrant, complex, and astonishingly diverse ecosystem, teeming with life that has evolved over eons to thrive in conditions that would instantly extinguish almost any surface dweller. These are not mere specks of existence. They are sophisticated organisms, each perfectly adapted to their unique, challenging environment. Imagine, if you will, a world where the sun's light is an ancient memory, a forgotten legend. Here, in this eternal twilight, life has found ways to flourish, to reproduce, to hunt, and to coexist. The inhabitants of this zone are a testament to the sheer tenacity and boundless creativity of evolution. They are the silent architects of a hidden world, their existence a constant, gentle reminder that life's potential is far greater than our immediate understanding. This is not a place of absence, but of presence, a profound and active community existing just beyond our everyday reach, a secret garden nurtured by darkness and pressure. The sheer density and variety of life within the midnight zone, also known as the bathyal or abyssal zone, are truly remarkable. It's a misconception to think that the absence of sunlight equates to an absence of life. While photosynthesis, the process that forms the base of most surface food webs, is impossible here, life has found alternative and equally ingenious ways to sustain itself. The primary energy source for many of these deep-sea communities is not sunlight, but rather the organic matter that drifts down from the upper layers of the ocean. This detritus, often referred to as marine snow, consists of dead organisms, fecal pellets, and other organic particles. While it may sound unappealing, this marine snow forms a vital food source for a vast array of creatures, from tiny zooplankton to larger scavengers. Furthermore, in specific locations, life is fueled by entirely different processes. Hydrothermal vents, for instance, release superheated, mineral-rich water from beneath the Earth's crust. Here, specialized bacteria and archaea perform chemosynthesis, converting chemicals like hydrogen sulfide into energy. These chemosynthetic organisms form the base of unique food webs that support entire ecosystems independent of sunlight. The creatures that inhabit these deep-sea environments have undergone extraordinary adaptations. Many possess large, sensitive eyes designed to capture the faintest glimmers of bioluminescence, while others have lost their sight altogether, relying instead on highly developed senses of touch, smell, and the detection of vibrations. Their bodies are often gelatinous or soft to withstand the immense pressure, and their metabolisms are typically slow, conserving energy in an environment where food can be scarce. Species like the anglerfish, with its bioluminescent lure, the viperfish with its fearsome teeth, and the delicate, ethereal forms of deep-sea jellyfish, all demonstrate the astonishing diversity of life that has successfully colonized this extreme frontier. It's a world where the rules of survival are rewritten, and life, in its most tenacious and imaginative forms, prevails. The inhabitants are not just surviving, they are thriving, creating intricate ecological balances and demonstrating a resilience that is nothing short of profound. And so, in this realm of perpetual twilight, life does not merely persist. It flourishes, a vibrant tapestry woven from the threads of adaptation and innovation, proving that existence finds a way, even in the most unexpected of places. Pressure here is a force beyond comprehension. Imagine for a moment the immense weight of the ocean pressing down. At the surface, we experience a single atmosphere of pressure, a gentle embrace we barely notice. But as we descend, that embrace tightens, becoming a relentless, colossal force. In the midnight zone, this pressure is not merely a sensation. It is an architect of existence, a sculptor of life, a fundamental condition that defines everything. For every 10 meters we descend, the pressure increases by one whole atmosphere. So, at a depth of 100 meters, we are under 10 times the pressure we feel on land. At 1,000 meters, 100 times. And at the deepest trenches, the pressure can exceed 1,000 atmospheres. To put this into perspective, 1,000 atmospheres is equivalent to the weight of a large elephant standing on your thumbnail. It is a force so profound that it would instantly crush any organism not specifically adapted to it. Yet, life not only survives but thrives in this crushing environment. The creatures of the midnight zone have evolved extraordinary adaptations to cope with this immense hydrostatic pressure. Their bodies are often composed of water, which is largely incompressible. Unlike air-filled cavities, which would collapse catastrophically, their tissues and cellular structures are designed to withstand and even utilize this external force. Some deep-sea fish have bodies that are more gelatinous, lacking rigid skeletal structures that might buckle. Others have specialized proteins and enzymes that function optimally under extreme pressure, their very molecular machinery re-engineered by evolution to work within this formidable embrace. The pressure also plays a role in the solubility of gases, influencing respiration and metabolic processes in ways we are only beginning to understand. It influences the way sound travels, the way light penetrates, and the very chemical reactions that sustain life. It is a constant, unyielding presence, shaping the forms and behaviors of its inhabitants. The pressure of the midnight zone is not a destructive enemy, but a fundamental aspect of its environment, a powerful force that has driven the evolution of some of the most alien and resilient life forms on our planet. It is a reminder that life, in its most tenacious forms, can find a way to flourish even under conditions that seem utterly hostile to our surface-dwelling sensibilities. The very essence of survival in this realm is intimately tied to the ability to exist in harmony with this overwhelming force, to be shaped by it, rather than be destroyed by it. The pressure is not a void, but a vibrant, living medium. This immense, unyielding pressure is the silent sculptor of the deep, reminding us that even in the most extreme conditions, life finds a way to be, and in being finds its own majestic form. Creatures evolved unique ways to navigate darkness. In the profound, inky expanse of the midnight zone, where sunlight has not graced these depths for millennia, life has not merely survived but flourished, developing an astonishing array of adaptations to navigate what we perceive as an absolute void. For the organisms that call this realm home, darkness is not an absence, but a condition, a canvas upon which their existence is painted with senses and strategies far removed from our own. Imagine a world where vision, as we understand it, is either a secondary sense or entirely absent, replaced by an intricate symphony of other perceptions. These creatures are not simply blind, they are attuned to different frequencies of reality. Their evolution has sculpted them into masters of a silent, pressure-laden world, where the slightest vibration, the faintest chemical trail, or the subtlest shift in water currents can mean the difference between sustenance and starvation, between predator and prey. Consider the remarkable sensory systems that have arisen. Many inhabitants of the midnight zone possess lateral lines, sensitive organs that run along the length of their bodies, capable of detecting minute pressure changes and water movements. This allows them to sense the presence of other organisms, the flow of currents, and even the contours of the seafloor, all without the need for light. It's akin to having an invisible, three-dimensional map constantly updated by the very water that surrounds them. Some fish have developed enormous eyes, far larger than their heads, evolved to capture the faintest glimmer of bioluminescence from their prey or potential mates. Others, conversely, have reduced their eyes to mere vestiges, or lost them altogether, having found that the energy expenditure required for sight is simply not worth the minimal return in such a light-starved environment. For these, their reliance shifts dramatically to other senses. The sense of smell, or olfaction, becomes paramount. Many deep-sea creatures possess highly developed olfactory organs, allowing them to detect chemical cues released by prey from vast distances. A single molecule of a decaying organism, or a subtle pheromone released by a potential mate, can be a beacon in the darkness. This chemical radar is incredibly sophisticated, enabling them to track down food sources or find partners in a seemingly featureless expanse. Then there is the remarkable phenomenon of electroreception, where certain species can detect the weak electrical fields generated by the muscle contractions of other living beings. Sharks and rays, for instance, possess ampullae of Lorenzini specialized pores filled with a jelly-like substance that conducts electrical currents to nerve receptors. This allows them to see the electrical signature of hidden prey, even if it's buried in the sediment. The concept of seeing here must be broadened beyond the visual spectrum. It is about perceiving the environment through an array of stimuli that are invisible to us. Some fish have evolved barbels, fleshy tendrils that hang from their mouths or chins, often studded with taste and touch receptors, acting as highly sensitive lures or feelers to explore the immediate surroundings. Imagine a blind explorer using a long, sensitive probe to map out the terrain ahead, tasting and feeling every nuance. Even the sounds of the deep are perceived differently. While many deep-sea creatures are not auditory in the way we are, some can detect low-frequency sounds that travel vast distances through water, giving them an awareness of their surroundings that is both subtle and profound. The adaptations are not limited to sensory perception. Many creatures have evolved unique physical forms to assist in their dark domain. The anglerfish, for example, possesses a bioluminescent lure that dangles in front of its mouth, attracting unsuspecting prey. This is not navigation in the traditional sense, but a masterful manipulation of the darkness itself, turning it into an irresistible trap. The viperfish, with its needle-like teeth and disproportionately large mouth, is perfectly adapted to snatch any unfortunate creature that crosses its path, its eyes often positioned to detect the slightest upward movement. The gulper eel, with its distensible stomach and enormous jaw, can swallow prey much larger than itself, a crucial advantage when meals are scarce and unpredictable. Even the very movement of these creatures is a form of navigation. The subtle pulsing of fins, the slow, deliberate drift, the sudden burst of speed, each is a calculated interaction with the water, a way of feeling the world. For many, a passive drift is a primary mode of existence, allowing them to conserve energy while remaining aware of their surroundings through the gentle currents. Others, like the deep-sea squid, use jet propulsion, a powerful and efficient method of movement that also allows them to sense the subtle changes in pressure as they move through the water. The darkness of the midnight zone is not a void of ignorance, but a realm of specialized knowledge, where life has rewritten the rules of perception. These creatures, in their silent, pressured world, have found ways to see, to feel, to understand, and to thrive, using a language of senses that speaks volumes about the boundless creativity of evolution. In this eternal night, life's ingenuity paints a vibrant, unseen tapestry, proving that perception is not limited by light, but by imagination. Bioluminescence is the language of the deep. Imagine a world where the sun's rays, the very source of our visual understanding, cease to penetrate. Below a certain threshold, perhaps 1,000 meters, the light of day becomes a distant memory, a concept rather than a lived experience. This is the realm of the midnight zone, a vast expanse of perpetual twilight, and then true darkness. Yet this profound blackness is not a void of stillness or silence. Instead, it is a canvas upon which life has painted its own illumination, a silent, shimmering conversation that is as ancient as the oceans themselves. Bioluminescence, the production and emission of light by living organisms, is not merely a curious phenomenon in the deep sea. It is, in many ways, the very language through which these creatures communicate, navigate, hunt, and defend themselves. It is a biological marvel, a testament to evolution's boundless creativity in the face of extreme environmental pressures. The chemistry behind this living light is a fascinating dance of molecules. At its heart is a light-emitting molecule called luciferin, and an enzyme that catalyzes the reaction, called luciferase. When luciferin is oxidized, a process often facilitated by luciferase, it releases energy in the form of light. This light is typically cool, meaning very little heat is generated, a crucial adaptation in an environment where conserving energy is paramount. The colors of bioluminescence vary, though blues and greens are most common, as these wavelengths travel farthest in seawater. Some organisms can produce light in a more controlled fashion, flashing it intermittently, while others emit a steady glow. The complexity of bioluminescent displays can be astonishing. Many deep-sea fish possess photophores, specialized light-producing organs, which can be simple dots or intricate patterns. These patterns can be unique to a species, acting as identification markers in the vast, anonymous darkness. Some fish can even change the intensity and color of their light, a sophisticated form of communication. Consider the anglerfish, perhaps one of the most iconic inhabitants of the deep. Many species possess a lure, a modified dorsal fin spine that dangles in front of their gaping mouths, tipped with a bioluminescent organ filled with symbiotic bacteria. This pulsating light mimics the appearance of small prey, drawing unsuspecting victims closer into the anglerfish's deadly embrace. This is not just hunting. It is a silent, luminous beckoning in the abyss. Other creatures use bioluminescence for defense. The vampire squid, for instance, can eject a cloud of bioluminescent mucus, a dazzling display that momentarily blinds and disorients predators, allowing the squid to escape into the darkness. Some jellyfish and dinoflagellates can produce a startling flash of light when disturbed, a sort of burglar alarm that might attract a larger predator to prey on the creature that disturbed them, a form of defense by proxy. This burglar alarm effect is a remarkable strategy, turning potential danger into an unexpected ally. The social implications of bioluminescence are equally profound. For species that live in groups or form mating pairs, light can be a vital signal. Flashing patterns might indicate readiness to mate, or serve as a way to find and recognize individuals of the same species in the immense, featureless expanse. Imagine a world where the only way to find a compatible partner is through a precisely timed series of light pulses. It is a form of courtship that is both alien and deeply romantic, a silent, luminous serenade across the dark. Even the seemingly passive act of marine snow, the continuous shower of organic detritus from the upper ocean, can be a source of light. Some of the particles themselves may carry bioluminescent bacteria, creating ephemeral, twinkling constellations as they descend. The study of bioluminescence is still in its infancy, and each new discovery reveals more complexity. We are only just beginning to decipher this intricate language, to understand the nuances of its grammar and syntax. It is a reminder that even in the deepest, darkest corners of our planet, life finds a way to not only survive but to thrive, to communicate, and to create beauty. This living light, born from the very essence of biological chemistry, is a profound testament to the enduring power of adaptation and the silent, majestic conversations of the deep. It is a reminder that even in the absence of the sun, a vibrant and communicative world exists, painting itself in luminous strokes against the eternal canvas of the abyss. Anglerfish use lures to deceive and devour. In the perpetual twilight of the midnight zone, where sunlight is a forgotten memory, and the very concept of day and night dissolves into an unending, inky blackness, survival is a constant, delicate dance of adaptation and ingenuity. Among the most iconic and, dare I say, astonishing of the midnight zone's inhabitants are the anglerfish. These creatures, often depicted with a certain primal ferocity, are perfect embodiments of the extreme pressures and unique opportunities that define this alien realm. Their most striking feature, the one that has captured the imagination and perhaps instilled a sliver of primal fear, is their bioluminescent lure, a biological marvel that serves as both a beacon and a trap. The anglerfish, a broad term encompassing over 200 species, exhibits a remarkable diversity, yet the fundamental principle of their predatory strategy remains remarkably consistent. The lure, technically known as an esca, is an appendage that extends from the head of the female anglerfish, arising from a modified dorsal spine called the elysium. This elysium can be remarkably long and flexible, allowing the anglerfish to position the esca precisely where it will be most effective. The esca itself is a fleshy bulb, and within it resides a colony of symbiotic bioluminescent bacteria. These bacteria, thriving in the dark environment of the esca, produce a soft, ethereal light. The anglerfish does not produce this light itself. Rather, it cultivates and harbors these microscopic organisms, creating a living lantern. The color and intensity of this light can vary between species, ranging from a pale blue to a vibrant green, and sometimes even exhibiting a pulsating rhythm. This light serves a dual purpose. Firstly, in an environment where visual cues are scarce, it attracts prey. Small fish, crustaceans, and other invertebrates, drawn by the gentle glow, mistake it for a potential food source, perhaps a tiny planktonic organism or a patch of enticing algae. They approach, their curiosity piqued, their survival instincts momentarily overridden by the allure of the light. However, the light is not merely an invitation, it is a sophisticated deception. The anglerfish remains perfectly still, often partially buried in the sediment or camouflaged against the dark backdrop of the abyssal plain. Its body is often dark and nondescript, allowing it to blend seamlessly into its surroundings. Only the glowing esca is visible, a solitary point of attraction in the vast darkness. As the unsuspecting prey draws closer, mesmerized by the light, it ventures within striking distance. Then, with astonishing speed and a gaping maw that can often be larger than its own body, the anglerfish strikes. Its jaws are lined with long, sharp, inward-pointing teeth, designed to prevent any escape. The prey, once within its grasp, has virtually no chance of survival. The lure, which initially promised sustenance, becomes the instrument of its demise. The evolutionary pressures that have shaped this incredible adaptation are profound. In the deep sea, energy is a precious commodity. The cost of actively hunting, of expending energy in pursuit, can be prohibitively high. The anglerfish's strategy is one of supreme energy efficiency. By remaining largely motionless and using a passive lure, it conserves vital energy while maximizing its chances of encountering a meal. It is a testament to the power of natural selection, shaping life in the most unforgiving of environments into forms that are both alien and profoundly elegant in their brutal effectiveness. The light, so beautiful and alluring, is in reality a deadly trap, a silent promise of sustenance that leads only to oblivion for the unwary. And so, in the profound silence of the abyss, a tiny, living lantern dances, a beacon of deception in the eternal night, guiding its own prey into a darkness from which there is no return. The vampire squid's defense is a cosmic bloom. Imagine a creature that seems to have drifted from the pages of a dream, or perhaps from a distant, starlit nebula. This is the asterisk Vampirotuthis infernalis, the vampire squid from hell. Yet its name, though evocative, hints at a ferocity it doesn't truly possess. Unlike its more predatory cephalopod cousins, the vampire squid is a gentle detritivore, sifting through the falling organic matter, the marine snow, that drifts down from the sunlit layers above. It inhabits the oxygen minimum zone, a layer of the ocean between 600 and 1,000 meters deep, where oxygen levels are so low that most other marine life cannot survive. Here, in this perpetual twilight, it has evolved a defense mechanism so extraordinary, so visually arresting, that it truly resembles a celestial event unfolding in the inky blackness. When threatened, the vampire squid doesn't flee with speed or attack with sharp beaks. Instead, it performs a unique maneuver. It inverts its webbed arms, pulling them over its body, creating a defensive cloak. But this is no ordinary cloak. Within the webbing are specialized filaments, and when fully deployed, these filaments are lined with bioluminescent organs called photophores. These photophores can emit a dazzling blue light, but with a twist. The squid can control the intensity and pattern of this light. In its defensive posture, it can release a cloud of sticky, bioluminescent mucus. This mucus, when disturbed by a predator, erupts into a swirling, shimmering nebula of light. It's a disorienting, dazzling spectacle, a cosmic bloom of light designed not to harm, but to confuse and distract. The predator, suddenly confronted by this radiant explosion, is momentarily blinded and bewildered, allowing the vampire squid to slip away into the darkness, its own light extinguished, leaving only the fading memory of a fleeting, luminous wonder. It's a defense that transforms the creature's very being into a fleeting, ethereal display, a burst of starlight in the deepest night, a testament to life's ability to find beauty and survival even in the most challenging of environments. This strategy is not about aggression, but about illusion and escape, a silent ballet of light and shadow that plays out on the grand stage of the abyss, a reminder that even in the absence of sunlight, life finds ways to shine. The light it produces is not a weapon, but a beacon of its existence, a fleeting, ephemeral masterpiece painted against the canvas of eternal night, a silent signal of its resilience and its unique place in this profound and ancient world. In the deepest dark, a gentle bloom of light can be a creature's most powerful and most beautiful shield. Gulper eels possess jaws that defy anatomy. Imagine a mouth that can stretch to encompass a meal many times its own size, a gaping portal that seems to swallow the very darkness it inhabits. This is the extraordinary adaptation of the gulper eel, a creature perfectly suited to the scarce and unpredictable environment of the midnight zone. These eels, belonging to the family Saccharopharingidae, are characterized by their enormously distensible jaws and a body that tapers dramatically to a slender tail, often ending in a fin that resembles a tadpole. Their skeletal structure, particularly around the jaw, is remarkably flexible, allowing for an almost unbelievable expansion. The bones of their skull are not fused in the way we might expect, and the ligaments connecting the jawbone to the skull are exceptionally elastic, enabling the mouth to open to an angle of nearly 90 degrees. This is not a subtle widening. It is a transformation, a radical reshaping to accommodate prey that might be encountered infrequently, but is too significant to pass up. The stomach of a gulper eel is equally elastic, capable of swallowing prey whole, even if that prey is larger in diameter than the eel's own body. This ability is crucial in an ecosystem where food is a precious commodity, and a successful hunt, however rare, must yield maximum sustenance. The gulper eel's entire physiology is geared towards opportunistic feeding. They do not actively pursue prey with speed or agility. Instead, they drift, their massive mouths agape, waiting for an unsuspecting organism to swim within range. The sheer disproportion of their mouth to their body is not just a physical marvel. It represents a profound evolutionary strategy, a testament to life's ability to exploit every available niche, even in the most challenging conditions. The gulper eel's anatomy is a masterclass in adaptation, a living example of how extreme environments can sculpt life into forms that seem to belong to another world, a world where the rules of proportion are rewritten by the relentless pressure of survival. Their jaws are not merely a feature. They are a statement, a declaration that even in the crushing darkness, an opportunity for a substantial meal can be seized with astonishing capacity. The very structure of their being is a narrative of survival, a story told in the flexibility of bone and ligament, in the sheer, unadulterated potential of a mouth designed to embrace the unexpected, to hold onto life when it offers itself, no matter how large. In the profound silence of the abyss, the gulper eel's impossible jaw is a silent promise of sustenance, a reminder that even in scarcity, life finds a way to embrace abundance. Scavengers feast on the bounty of the surface. Imagine a world where the sun's rays, the very source of energy for so much of life, never penetrate. This is the realm of the midnight zone, a place of perpetual darkness and immense pressure. Yet life here is not a mere struggle for survival. It is a complex, interconnected web, and a vital part of this web is the remarkable recycling system that sustains it. For even in this seemingly isolated abyss, the surface world plays a crucial, if indirect, role. The bounty of the sunlit upper oceans, through a process known as marine snow, drifts down, providing sustenance for the creatures that dwell in the perpetual twilight and midnight zones. This is not a dramatic, sudden delivery, but a slow, steady, and ultimately life-giving descent. When we think of the deep sea, our minds often conjure images of predators with elaborate lures or strange, gelatinous forms drifting in the void. While these are certainly present, a significant portion of the biomass, the very substance of life, in the midnight zone is composed of scavengers. These are the unsung heroes of the abyss, the diligent recyclers, the creatures that make possible the existence of so many others by efficiently consuming the organic detritus that rains down from above. This organic matter, or marine snow, is essentially a constant shower of dead plankton, fecal pellets, shed exoskeletons, and fragments of larger organisms that have perished in the upper layers. It's a complex mixture, a sort of cosmic dust of the ocean, and it represents the primary energy input for much of the deep-sea ecosystem. Consider the scale of this phenomenon. Billions upon billions of microscopic organisms, from phytoplankton to zooplankton, live and die in the sunlit zones. Their remains, along with the waste products of their lives, are heavier than water and begin a slow, often turbulent journey downwards. This descent can take days, weeks, or even months, depending on the size and density of the particles. As they fall, they may be consumed by smaller organisms, but a significant portion continues its downward migration. For the scavengers of the midnight zone, this is their sustenance. They are adapted to detect these faint traces of organic matter, often through highly developed chemosensory abilities. They have specialized mouthparts and digestive systems designed to extract every last bit of nutrition from these often sparse offerings. Among the most prominent scavengers are various species of amphipods, small, shrimp-like crustaceans that can swarm in large numbers around a fresh deposit of organic material. They are incredibly efficient at breaking down larger pieces and consuming smaller particles. Then there are the holothurians, or sea cucumbers, which are essentially slow-moving, soft-bodied vacuum cleaners of the seabed. They ingest large quantities of sediment, sifting through it for any organic particles that have settled. Their digestive processes are slow, but their tireless work plays a crucial role in processing the marine snow that reaches the ocean floor. Larger scavengers also exist, such as deep-sea fishes like rattles and grenadiers, which possess keen senses of smell to locate carcasses or aggregations of smaller scavengers. They are opportunistic feeders, taking advantage of any significant organic fall. Even the iconic anglerfish, while known for its predatory lure, will readily consume carrion if it presents itself. The entire ecosystem is built upon this principle of consumption and recycling. Without the continuous rain of marine snow and the diligent work of the scavengers, the midnight zone would be a far less diverse and vibrant place. The diversity of scavengers reflects the diversity of the marine snow itself. Different species are adapted to consume different types of particles, from the finest organic dust to larger fragments of decaying organisms. This specialization allows for the efficient processing of a wide range of organic matter, ensuring that as much energy as possible is captured and retained within the deep-sea ecosystem. It's a testament to the incredible adaptability of life, finding a way to thrive even in the most challenging and seemingly resource-scarce environments. This continuous cycle, from the sunlit surface to the crushing depths, is a fundamental principle of oceanic life, a quiet, constant exchange that sustains a world we are only just beginning to comprehend. The silent fall of surface life's remnants nourishes the deepest darkness, a cosmic ballet of consumption and renewal that whispers of interconnectedness. The marine snow is a gentle, constant rainfall. Imagine, if you will, a slow, almost imperceptible descent from the sunlit upper layers of the ocean, a continuous shower of organic detritus that blankets the abyssal plains and trenches. This is marine snow, a phenomenon that, despite its seemingly humble composition, forms the very foundation of life in the midnight zone. It's not just dead matter. It's a vital nutrient delivery system, a constant, gentle rain of sustenance that sustains an entire ecosystem, far removed from the photosynthetic bounty of the surface. This cascade begins with the life that thrives in the euphotic zone, the sunlit layer where phytoplankton bloom. As these microscopic plants, along with zooplankton that graze upon them, complete their life cycles, or as larger organisms excrete waste, fragments of organic material begin to drift downwards. These fragments, ranging from individual cells to larger fecal pellets and even the carcasses of deceased organisms, form the initial components of marine snow. It's a complex mixture, a veritable soup of carbon, nitrogen, and other essential nutrients, all slowly making their way through the water column. The journey of marine snow is a testament to the immense scale and patience of oceanic processes. As these particles descend, they are often aggregated by sticky substances, such as mucus secreted by plankton or bacteria, forming larger, more substantial flakes. This aggregation is crucial, as it increases the density of the particles, allowing them to sink more rapidly and reducing the chances of them being consumed by organisms in the upper water column. It also creates larger, more appealing morsels for the filter feeders and detritivores of the deep. Think of it as a cosmic ballet, a slow-motion dispersal of energy and matter. The rate at which marine snow descends varies, influenced by factors like particle size, density, and ocean currents. Some particles may reach the seafloor within days, while others can take months or even years to complete their journey. During this descent, these particles become a habitat in themselves, colonized by bacteria and other microorganisms that further break down the organic material, releasing nutrients back into the water and making them accessible to a wider range of organisms. The sheer volume of marine snow is astonishing. Scientists estimate that billions of tons of organic carbon fall from the surface waters to the deep ocean each year. This constant influx of organic matter is what allows life to persist in the midnight zone, a realm where sunlight, the primary energy source for most of Earth's ecosystems, is utterly absent. Without this gentle, persistent rainfall, the deep sea would be a barren, lifeless desert, devoid of the extraordinary creatures that have adapted to its extreme conditions. The composition of marine snow is incredibly diverse. It can include fragments of algae, bacteria, protozoa, the remains of small crustaceans and other zooplankton, fecal pellets, and even larger pieces of organic debris. When a whale or other large marine mammal dies and sinks to the ocean floor, its carcass becomes a temporary bonanza, attracting scavengers from miles around. But the everyday sustenance of the deep is provided by the continuous, less dramatic fall of marine snow. The process of marine snow formation and transport is a critical link in the global carbon cycle. It represents a significant pathway for carbon to be sequestered from the atmosphere and stored in the deep ocean, playing a vital role in regulating Earth's climate. The efficiency of this biological pump, as it's known, is a subject of ongoing scientific research, but its fundamental importance to the planet's health is undeniable. In the midnight zone, where every calorie counts, marine snow is not merely waste. It is life's lifeline. It is the silent, unseen sustenance that fuels the extraordinary adaptations of deep-sea organisms, from the smallest bacteria to the largest deep-sea fish. It is a constant reminder that even in the deepest, darkest corners of our planet, life finds a way, sustained by a slow, gentle, and unending celestial gift from above. This quiet descent is the heartbeat of the abyss, a subtle yet profound connection between the sunlit world and the eternal night. And so, this constant, gentle rainfall of organic matter, the marine snow, is the quiet architect of life in the deepest oceans, a subtle yet profound testament to the interconnectedness of all things. Hydrothermal vents are oases of alien life. Imagine, for a moment, a landscape on our own planet, yet utterly alien. A place where the sun's rays have never, not once, penetrated. A realm of perpetual darkness, immense pressure and frigid temperatures, yet teeming with life. These are the hydrothermal vents, found scattered across the ocean floor, often in the deepest trenches, like chimneys spewing forth superheated water into the frigid abyss. They are, in essence, volcanic springs on the seabed. At these vents, the Earth's crust is thin, and magma lies close to the surface, heating seawater that seeps into the rock. This superheated water, rich in dissolved minerals and chemicals, then erupts back into the ocean, creating these remarkable oases. The water emerging from these vents can reach temperatures exceeding 400 degrees Celsius, yet due to the extreme pressure of the deep sea, it doesn't boil. Instead, it forms a dense, mineral-laden plume. As this superheated water mixes with the surrounding cold seawater, it precipitates out dissolved minerals, particularly sulfur compounds, forming the towering chimneys that give these vent fields their distinctive appearance. These structures can grow to be hundreds of feet tall, resembling fantastical castles sculpted by the ocean's unseen forces. They are often coated in a strange, colorful mineral deposit, a testament to the intense chemical reactions occurring within. But what truly sets these hydrothermal vent ecosystems apart is their source of energy. Unlike almost all life on Earth, which relies on photosynthesis, the conversion of sunlight into energy, the life around hydrothermal vents thrives on chemosynthesis. This is a process where specialized bacteria and archaea, known as chemoautotrophs, harness the chemical energy released from inorganic compounds, primarily hydrogen sulfide, found in the vent fluids. These microorganisms form the base of the entire food web. They are the primary producers, creating organic matter from chemicals in a process that is as profound as it is alien to our surface-dwelling understanding. These chemosynthetic microbes form dense mats and biofilms on the surfaces of the vents, creating a nutrient-rich environment that supports a host of other extraordinary organisms. Giant tube worms, some reaching over 8 feet in length, are a prime example. They lack a mouth and a digestive system, instead relying on symbiotic bacteria living within their bodies. These bacteria consume hydrogen sulfide from the vent fluids, and in return, provide the worm with all the nutrients it needs to survive. Their vibrant red plumes, which wave gently in the currents, are actually gills that absorb the necessary chemicals from the water. Other inhabitants of these vent oases include specialized species of mussels, clams, shrimp, crabs, and fish, all uniquely adapted to this harsh, yet life-sustaining environment. Many of these creatures possess specialized organs or symbiotic relationships that allow them to tolerate or even thrive in the presence of toxic chemicals and extreme temperature gradients. The diversity of life, though perhaps not as visually varied as a coral reef, is astoundingly high, with many species found nowhere else on Earth. These are endemic species, evolved in isolation within these pockets of intense geological activity. The discovery of hydrothermal vents and their chemosynthesis-based ecosystems in the late 1970s revolutionized our understanding of life's potential and the conditions under which it can arise and persist. It demonstrated that life doesn't require sunlight and opened up possibilities for life existing in other extreme environments, both on Earth and potentially on other planets or moons where similar chemical energy sources might be available. These vents are not just geological curiosities. They are vibrant, self-contained worlds, powered by the Earth's internal heat and chemistry, a testament to life's boundless capacity to adapt and flourish in the most unexpected of places. These deep-sea vents, spewing forth life-giving chemicals from the Earth's core, reveal a universe of existence where darkness and pressure are not barriers, but cradles for an entirely different kind of wonder, mirroring the hidden depths of peace that can be found within ourselves. Chemosynthesis powers ecosystems without sunlight. Imagine for a moment a world utterly devoid of the sun's radiant embrace. Not a single photon, not a whisper of solar energy penetrates these crushing depths. Yet life, in its astonishing tenacity, not only persists but flourishes. This is the profound paradox of the midnight zone, a realm where the very foundations of our understanding of life are rewritten. We are accustomed to picturing ecosystems as intricate tapestries woven with threads of sunlight, from the microscopic phytoplankton performing photosynthesis at the surface, to the vast food webs that ultimately depend on that initial solar spark. But in the abyssal plains and along the ocean floor, far beyond the reach of any sunbeam, entirely different engines of life are at work. These are the engines of chemosynthesis, a biological marvel that harnesses the chemical energy locked within inorganic molecules, rather than the radiant energy of light. This process is the cornerstone of life in many deep-sea environments, particularly around hydrothermal vents, those volcanic fissures that spew superheated, mineral-rich water into the frigid abyss. Here, in this seemingly inhospitable environment, specialized bacteria and archaea, known as chemoautotrophs, perform a feat that would seem miraculous to any surface dweller. Instead of carbon dioxide and water being converted into sugars using light energy, these remarkable microbes utilize compounds like hydrogen sulfide, methane, and ammonia, often found in abundance near vents, as their primary energy source. They take these raw, often toxic, chemical components from the Earth's interior, and through a complex series of biochemical reactions, transform them into organic matter, effectively creating their own food. This is not merely a biological curiosity. It is the bedrock upon which entire, complex ecosystems are built. These chemosynthetic microbes form the base of a food chain that supports an array of extraordinary creatures. Giant tube worms, their vibrant red plumes reaching into the nutrient-rich plumes, host symbiotic bacteria within their bodies, relying entirely on their internal chemical factories for sustenance. Clams, mussels, and shrimp, all adapted to these unique conditions, graze on bacterial mats or filter the chemical-laden waters. Even larger predators like deep-sea fish and squid find their way to these oases, drawn by the abundance of life. The process of chemosynthesis is a testament to life's adaptability, demonstrating that the fundamental requirement for an ecosystem is not necessarily light, but a source of usable energy and the building blocks for organic molecules. It reveals a universe of biological possibility that extends far beyond the familiar paradigms of surface life. These deep-sea ecosystems, powered by the silent, unseen chemistry of the Earth, are vibrant, complex, and utterly alien, existing in a perpetual twilight that is nonetheless teeming with life. It's a reminder that the definition of habitable is far broader and more imaginative than we might initially conceive, and that the planet itself, in its deepest, darkest recesses, provides the very fuel for existence. The energy that sustains these communities is not a distant glow, but an intimate, earthbound force, a constant chemical pulse that underpins an entire world. In the silent, crushing dark, life finds its sustenance not in borrowed light, but in the raw, elemental breath of the planet itself. Deep-sea corals build structures in eternal night. Imagine, if you will, a world untouched by the sun's golden touch, a realm of perpetual twilight, or more accurately, of absolute darkness. Yet, within this seemingly inhospitable environment, life has found a way to not merely survive, but to flourish, to construct, and to create architectural wonders that rival the grandest cathedrals of our waking world. These are the deep-sea corals, the architects of the abyss, who, in the absence of solar energy, have devised an entirely different blueprint for existence. Unlike their shallow-water cousins, which rely on symbiotic algae called zooxanthellae to photosynthesize and provide them with vital nutrients, deep-sea corals are entirely heterotrophic. This means they must actively seek out and capture food from their surroundings. Their structures, often vast and intricate, are not just habitats, but also elaborate feeding mechanisms, designed to passively filter the sparse, nutrient-rich waters that drift by. These corals are typically found in depths ranging from 200 to over 6,000 meters, where the water pressure is immense. The temperature is near freezing, and the only light is that which they or other deep-sea organisms generate. They anchor themselves to the seafloor, often on rocky outcrops or the remains of ancient shipwrecks, and begin their slow, patient work of building. Over centuries, even millennia, these colonies of tiny polyps, each no larger than a grain of rice, secrete calcium carbonate skeletons. These skeletons interlock and grow, forming complex three-dimensional frameworks that provide shelter and substrate for an astonishing array of other marine life. Think of them as underwater cities, teeming with activity, a vibrant metropolis where fish, crustaceans, mollusks, and countless other invertebrates find refuge from predators, nurseries for their young and hunting grounds. Some of these reefs can span hundreds of square kilometers, forming entire ecosystems that are vital to the health of the ocean. The sheer scale of these structures, built so slowly and so patiently in such extreme conditions, is a testament to the enduring power of life. They are living monuments, sculpted by time and the gentle, persistent currents of the deep. The absence of sunlight here is not a void, but a canvas upon which life paints its most intricate and enduring masterpieces. These corals, in their quiet persistence, demonstrate a profound form of resilience, a commitment to creation that transcends the need for light, a testament to the universal drive to build and to connect, even in the deepest, darkest reaches of our planet. Their existence is a silent, majestic affirmation of life's capacity to thrive in the most unexpected places, shaping their environment with a slow, deliberate artistry that speaks of unimaginable patience. In the eternal night, life builds its most enduring monuments, a silent testament to creation's persistent grace. The gigantism of the deep is a response to cold. In the profound stillness of the midnight zone, where sunlight is but a forgotten rumor, a curious phenomenon unfolds: the tendency for some creatures to grow to extraordinary sizes, far exceeding their shallower-dwelling relatives. This isn't a mere coincidence. It's a sophisticated adaptation, a testament to the ingenious ways life finds to thrive even in the most extreme conditions. One of the primary drivers behind this deep-sea gigantism is the pervasive, bone-chilling cold. The waters of the abyss are remarkably stable in temperature, hovering just a few degrees above freezing. This constant, low temperature has a significant impact on an organism's metabolism. For many cold-blooded creatures, particularly invertebrates, their metabolic rate slows down considerably in colder environments. This slower metabolism means they require less energy to survive and grow, allowing them to allocate more resources towards increasing their physical mass over their lifespan. Think of it as a long-term investment in existence. Instead of a rapid, energy-intensive burst of activity, they adopt a slow, deliberate pace, growing incrementally over decades, even centuries. This extended growth period, coupled with a reduced need for rapid energy expenditure, can lead to individuals of impressive stature. Consider the deep-sea isopods, often described as giant woodlice. Some species can reach lengths of over 50 centimeters, a far cry from their terrestrial cousins. Similarly, certain species of deep-sea amphipods and decapods can grow to be significantly larger than their shallow water counterparts. The increased size also offers other advantages in this challenging environment. A larger body mass can help some creatures conserve heat, acting as an insulating layer in the frigid waters. It can also provide a greater capacity to store energy reserves, crucial for surviving long periods between scarce meals. Furthermore, in a world where predators might be few, but competition for resources can be fierce, sheer size can be a significant advantage. A larger organism may be better equipped to defend itself, to outcompete others for food, or to reach food sources that smaller creatures cannot. The deep-sea spider crab, for instance, with its impossibly long legs, can cover vast distances of the seafloor, searching for sustenance, its immense frame a formidable presence in the dark. This gigantism isn't universal, of course. Some deep-sea creatures are remarkably small, and others exhibit different adaptations entirely. But for those that do grow large, the cold, stable environment of the midnight zone provides the perfect, albeit slow motion, canvas for their magnificent expansion. It's a reminder that life's forms are sculpted not just by opportunity, but by the relentless, quiet pressures of existence, and that even the most extreme cold can foster the most majestic growth. In the enduring chill of the abyss, size becomes a slow, deliberate embrace of eternity. The slow metabolism of abyssal life. In the crushing, frigid, and utterly dark realm of the midnight zone, the very pace of existence shifts. Life here does not rush, it endures. The metabolic rates of creatures inhabiting these extreme depths are profoundly, astonishingly slow. Imagine a world where every ounce of energy is a precious, hard-won commodity. For the inhabitants of the abyss, this is not a metaphor but a fundamental reality. Their bodies have evolved to conserve energy with an efficiency that would seem miraculous to surface dwellers. This slowness is not a sign of weakness, but of exquisite adaptation, a testament to the ingenuity of life when faced with the most formidable challenges. Consider the energy budget of an abyssal organism. Food, when it arrives, is often scarce. The marine snow, the gentle, constant rain of organic detritus from the upper ocean, provides sustenance, but it is a diffuse and unpredictable resource. Unlike the abundant, readily available food sources in sunlit waters, the deep sea offers no easy meals. To survive, these creatures must make every bite count. This scarcity has driven the evolution of incredibly low metabolic rates. Their cellular processes, the fundamental chemical reactions that sustain life, operate at a glacial pace. Their hearts beat slower, their movements are more deliberate, and their digestive systems are optimized for maximum nutrient extraction from minimal intake. Some deep-sea fish, for instance, can go for months, even years, between significant meals. Their bodies are designed for extreme patience, for waiting, for surviving the long stretches of scarcity. This slow metabolism also affects their growth and reproduction. Growth is often incredibly slow, with some species taking decades, even centuries, to reach maturity. Reproduction, too, is a rare and energy-intensive event, often timed to coincide with rare periods of resource abundance. The energy investment in producing offspring is immense, and the strategies employed are as varied as the life forms themselves, from producing few, large, energy-rich eggs to complex parental care that ensures the highest possible survival rate for each precious offspring. The sheer longevity of some abyssal creatures is a direct consequence of their slow metabolism. They simply age much, much slower. Their entire life cycle is calibrated to the unhurried rhythm of the deep, a stark contrast to the frenetic pace of life in the sunlit world. This deliberate slowness is a fundamental principle of survival in the midnight zone, a quiet, enduring strategy that has allowed life to persist in one of Earth's most demanding environments for eons. It is a profound lesson in the power of patience and the remarkable adaptability of life itself. The slow metabolism of the abyss is a gentle reminder that existence can unfold at a rhythm far removed from our own hurried lives, a quiet whisper of endurance in the face of profound scarcity. Sensory adaptations transcend sight. In the perpetual twilight, and then the absolute darkness of the midnight zone, sight as we understand it becomes a luxury, often a liability. For the creatures that call this realm home, the absence of sunlight has driven an extraordinary evolution of senses, transforming the very ways they perceive their world. Imagine, if you will, a universe where light is a forgotten memory and existence is painted not with colors, but with vibrations, chemical trails, and subtle shifts in pressure. This is the domain where touch, taste, and an almost instinctual awareness of the surrounding environment take precedence, guiding survival in ways that can seem almost magical to our surface-dwelling minds. Consider the lateral line system found in many fish, including those that inhabit the deep. This is not an organ of sight, but rather a network of fluid-filled canals running along the sides of the body, studded with tiny sensory pores. Within these canals are specialized cells called neuromasts, which are incredibly sensitive to water movement. When a predator approaches or prey stirs, the disturbance in the water creates tiny pressure waves that ripple across the fish's body. The neuromasts detect these minute changes, allowing the fish to pinpoint the direction and intensity of the disturbance, even in absolute darkness. It's a form of hydrodynamic perception, a constant, subtle reading of the currents and pressures that flow around them. This system can also help them navigate, sense obstacles, and even detect the presence of other fish by the subtle movements they create. It's a biological sonar, but one that relies on feeling rather than sound. Then there are the olfactory senses, the sense of smell. In the deep sea, where visual cues are scarce, chemical signals become paramount. Many deep-sea creatures possess highly developed olfactory organs, allowing them to detect the faintest traces of dissolved chemicals in the water. These chemicals can signal the presence of food, the proximity of a mate, or even the danger of a predator. For instance, some species can detect the scent of decaying organic matter, the marine snow that drifts down from the upper layers from miles away. Others can follow complex chemical trails left by their prey, navigating through the vast, featureless expanse with an unerring sense of direction. This chemical tapestry is a silent, invisible language, spoken and understood by the denizens of the deep. Beyond these more familiar senses, there are adaptations that blur the lines between perception and instinct. Some deep-sea organisms possess electroreception, the ability to detect weak electrical fields generated by the muscle contractions of other living beings. This is particularly useful for detecting prey that might be hidden in the sediment or camouflaged against the dark backdrop. Imagine feeling the faint electrical pulse of a worm burrowing beneath the sand, or the subtle hum of a fish's heart beating in the distance. This sense allows them to see the living world around them, even when no light is present. The very texture of their existence is a form of sensory input. The extreme pressure of the midnight zone, which would instantly crush a surface dweller, is a constant environmental factor that these creatures are not only adapted to, but often utilize. Their bodies are often gelatinous or soft, lacking the rigid structures that would be damaged by the immense forces. They are attuned to these pressures in ways we can only begin to fathom, their very being a testament to the adaptability of life. In this realm, the absence of sight does not mean an absence of perception. It means a redefinition of what it means to sense, to know, and to exist. These creatures have woven a complex tapestry of awareness from the threads of pressure, vibration, and chemistry, demonstrating that the universe is perceived in a myriad of ways, far beyond the limitations of our own familiar senses. The deep sea teaches us that to truly perceive is to feel the world's gentle, unseen currents. Echolocation finds its place in the dark. In the unfathomable, silent expanse of the midnight zone, where sunlight is a forgotten myth and vision becomes a luxury few can afford, life has found extraordinary ways to perceive its surroundings. Among the most ingenious of these adaptations is the phenomenon of echolocation, a biological sonar system that allows creatures to see with sound. This is not merely about hearing. It is about actively emitting sound waves and interpreting the returning echoes to build a detailed sonic map of their environment. Imagine a world painted not by light, but by the subtle reverberations of sound. For many inhabitants of these crushing depths, this is their reality. The principle is elegantly simple, yet its execution in the deep sea is a marvel of evolutionary engineering. An animal emits a sound, a click, a chirp, or a whistle, and these sound waves travel outwards, bouncing off any object in their path, a potential meal, a looming predator, or the intricate topography of the seabed. The echoes that return carry vital information: the distance to the object, its size, its shape, its texture, and even its velocity. The finer the distinction between the emitted sound and the returning echo, the more precise the animal's understanding of its world. Consider the toothed whales, the cetaceans like dolphins and sperm whales, who are masters of this technique. They produce rapid series of high-frequency clicks from a structure in their forehead called the melon, a fatty organ that acts as an acoustic lens, focusing the sound into a beam. As these beams travel through the water, they encounter everything. The returning echoes are received by the whale's lower jaw, which is filled with fatty tissues that efficiently conduct sound to the inner ear. The brain then processes these complex signals with astonishing speed and accuracy, creating a three-dimensional image of the world. This allows them to navigate through the perpetual darkness, to hunt elusive prey that may themselves be camouflaged or moving rapidly, and to communicate with each other across vast distances. Even in the crushing pressures and frigid temperatures of the midnight zone, where visibility is zero, these creatures thrive, their existence defined by the symphony of sound they create and interpret. But echolocation is not exclusive to whales. Certain species of fish, like the deep-sea grenadiers, also possess the ability to use sound for navigation and foraging. While their systems may not be as sophisticated as those of the cetaceans, they serve the same fundamental purpose: to overcome the limitations of their environment. The sounds produced by these fish might be lower in frequency, but they are no less crucial to their survival. They can detect the subtle movements of small invertebrates on the seafloor, or the presence of larger predators lurking in the shadows. This sonic perception is so finely tuned that it can distinguish between different types of surfaces, allowing a fish to determine if it is swimming over soft sediment or a hard rock formation, a critical piece of information for both navigation and finding suitable habitats. The very structure of the deep-sea environment also plays a role in the effectiveness of echolocation. While water can attenuate sound over long distances, the relative lack of ambient noise from surface activity and the consistent properties of the water column create a predictable medium for sound transmission. This is a stark contrast to the chaotic sonic landscape of shallower waters. In the midnight zone, the echoes are clearer, the signals more distinct, allowing for a more refined interpretation. It is a testament to the power of adaptation that life, faced with the ultimate challenge of absolute darkness, has found a way to illuminate its world with the invisible waves of sound. In the profound silence of the deep, the echoes are not just sounds, but whispers of existence, painting a vibrant, unseen tapestry that guides life through the eternal night. The ghostly beauty of the Dumbo octopus. In the profound and silent expanses of the midnight zone, where sunlight has never dared to tread, life has sculpted itself into forms that defy imagination, and perhaps even our most cherished notions of what it means to exist. Among these marvels, the Dumbo octopus, a creature so ethereal it seems to have drifted from the realm of dreams, presents a spectacle of almost otherworldly grace. Its name, derived from the beloved Disney character, hints at its most striking feature: two large, ear-like fins that sprout from its head, undulating gently like the wings of an airborne dancer. These are not mere appendages, but sophisticated organs of locomotion, propelling the octopus through the crushing pressures and perpetual darkness with a serene, almost balletic motion. Unlike its shallow water cousins who often dart and hide, the Dumbo octopus drifts, a phantom in the abyss, its movements dictated by the subtle currents and its own internal rhythm. Its body, often described as gelatinous or translucent, allows the faint bioluminescence of its surroundings, or perhaps even its own internal light, to shimmer through, casting an otherworldly glow. This translucence is not just an aesthetic choice of evolution. It serves as a form of camouflage in the featureless void, allowing it to blend seamlessly with the inky blackness or the diffuse glow of deep-sea organisms. Its eyes, though present, are adapted for the dimmest of light, often appearing as dark orbs that seem to absorb the scant photons available, hinting at a perception of the world far removed from our own visual reliance. The Dumbo octopus inhabits depths that can range from 3,000 to over 4,000 meters, a realm where the water pressure is immense, capable of crushing most surface-dwelling life forms. Yet it thrives, its delicate structure perfectly adapted to these extreme conditions. Its diet consists of small crustaceans and worms that it finds by sifting through the sediment on the ocean floor, or by capturing prey that drifts within its reach. It is a solitary creature, its encounters with others likely rare, its existence a testament to the quiet persistence of life in the most challenging environments imaginable. The sheer improbability of its form, its gentle, unhurried grace, and its adaptation to a world devoid of light all contribute to its ghostly beauty. It is a living embodiment of the profound and often surprising ways life can manifest, a reminder that even in the deepest, darkest corners of our planet, there is elegance, there is wonder, and there is a quiet, enduring luminescence. The Dumbo octopus, a delicate ballet dancer of the deep, reminds us that beauty can flourish in the absence of light, a serene spectral presence in the ocean's profoundest silence. The unseen world of microscopic life. Even in the crushing dark, the midnight zone teems with a universe of life that escapes our immediate notice, a vibrant, bustling community existing on a scale almost too small to grasp. This realm is not defined by the giants that occasionally drift through it, but by the ceaseless activity of countless microscopic organisms, the true architects of the abyss. These are the plankton, the bacteria, the archaea, the single-celled wonders that form the very foundation of this extreme ecosystem. They are everywhere, suspended in the water column, clinging to the sparse detritus that drifts down from above, and colonizing every surface. The sheer abundance of these tiny life forms is staggering. Imagine billions, trillions, quadrillions of individual entities, each with its own unique role, its own silent struggle for existence. They are the primary producers, converting inorganic matter into organic energy, and they are the decomposers, recycling nutrients that would otherwise be lost forever. Without this unseen world, the larger creatures of the midnight zone would have no sustenance. Consider the zooplankton, tiny animals that drift with the currents. Many of these are larval stages of larger, more familiar deep-sea inhabitants, but many are also permanent residents, adapted to a life of constant suspension. They graze on the phytoplankton, the microscopic plants that, even in the deepest parts of the ocean, manage to eke out an existence through chemosynthesis or by utilizing the faintest traces of light that may penetrate from the distant surface. These phytoplankton, though invisible to the naked eye, are as vital to the midnight zone as forests are to a terrestrial landscape. They are the initial spark, the tiny engines that drive the entire food web. Then there are the bacteria and archaea, often considered the most ancient forms of life on Earth. In the midnight zone, they are not just present, they are the dominant force. They thrive in conditions that would be utterly lethal to most other organisms: extreme pressure, no oxygen, scorching heat near hydrothermal vents, or frigid cold in the abyssal plains. They engage in a bewildering array of metabolic processes, breaking down complex organic molecules, oxidizing sulfur compounds, and even consuming methane. Some are so specialized that they can form dense mats on the seafloor, creating miniature ecosystems within themselves. Near hydrothermal vents, these chemosynthetic bacteria form the base of an entire food chain, supporting communities of worms, mussels, and shrimp that have never seen sunlight. The sheer diversity of microbial life in the deep sea is still largely unknown. Scientists are constantly discovering new species, new metabolic pathways, and new adaptations that push the boundaries of what we thought was possible for life. These microscopic organisms are not just passive inhabitants. They are active participants in shaping their environment, influencing the chemistry of the water, the composition of the sediments, and the very cycle of life and death in the abyss. Their existence is a testament to life's incredible tenacity, its ability to find a foothold and flourish in even the most challenging circumstances. They are the quiet, persistent pulse of the midnight zone, a constant reminder that life's grandest narratives are often written in the smallest of scripts. In the silent ballet of the abyss, these infinitesimal beings orchestrate the grand cycles of existence, a constant hum of life that underscores the profound interconnectedness of all things, even in the deepest dark. The midnight zone is a reservoir of biodiversity. This profound statement, that the deepest, darkest reaches of our oceans, the very realm where sunlight has never penetrated, is teeming with an astonishing diversity of life, might seem counterintuitive at first. We often associate life with light, with the vibrant photosynthesis that fuels so much of the surface world. Yet the abyss, far from being a barren wasteland, is a vibrant tapestry woven with countless species, each uniquely adapted to survive and thrive in conditions that would be utterly inhospitable to most life forms we know. The sheer number of distinct species discovered, and undoubtedly many more yet to be found, within the midnight zone is staggering. This isn't just a few hardy survivors. It's a complex web of interactions, a testament to life's relentless drive to fill every conceivable niche. Consider the sheer variety of forms, from the delicate, gelatinous bodies of comb jellies, pulsing with internal light, to the robust, armored bodies of deep-sea isopods and the impossibly large mouths of anglerfish. Each one represents a unique evolutionary journey, a specialized solution to the challenges of perpetual darkness, immense pressure, and scarce food. The biodiversity here isn't just about the number of species, but also the incredible range of adaptations. We see creatures that have evolved to detect the faintest vibrations in the water, others that rely on chemical senses far more acute than our own, and some that have developed entirely novel ways of creating their own light for communication, hunting, or defense. The concept of a reservoir implies a vast, untapped source, and in the case of the midnight zone's biodiversity, this is profoundly true. Scientists estimate that a significant percentage of deep-sea species remain undiscovered, hidden within the vast, largely unexplored expanses of this abyssal realm. Each new expedition, each new remotely operated vehicle dive, reveals organisms that defy our current understanding of biology, pushing the boundaries of what we thought was possible for life. This rich tapestry of life is not static. It is dynamic, with intricate food webs and symbiotic relationships that have evolved over eons. The marine snow, the constant, gentle rain of organic matter from the upper layers, acts as a vital, albeit sparse, food source, supporting a food chain that extends down into the deepest trenches. Specialized bacteria, archaea, and fungi form the base of many of these food webs, breaking down organic material and providing sustenance for larger organisms. The existence of entire ecosystems around hydrothermal vents, powered by chemosynthesis rather than photosynthesis, further underscores the remarkable adaptability and diversity of life in the midnight zone. These vents, spewing superheated, mineral-rich water from the Earth's crust, support communities of tube worms, mussels, shrimp, and crabs that are found nowhere else on the planet. Their existence is a powerful reminder that life, in its myriad forms, can find a way even in the most extreme environments. The midnight zone is, therefore, not just a place of darkness and pressure, but a vibrant, dynamic, and incredibly biodiverse frontier, a living library of evolutionary innovation that continues to surprise and inspire us with its resilience and ingenuity. It's a reminder that life's creativity knows no bounds, extending into the most alien corners of our own planet, offering a profound perspective on the sheer tenacity and wonder of existence itself. In the silent, crushing dark, life has painted an unseen masterpiece of immeasurable variety. Its inhabitants hold clues to Earth's history. The deep ocean, a realm of perpetual night, is not merely a silent, alien landscape. It is, in essence, a living archive, a vast, slow-moving repository of Earth's past. The creatures that call the Midnight Zone home, from the most ancient-looking of fish to the microbial communities that churn within hydrothermal vents, are living descendants of lineages that have navigated these depths for eons, long before the first land plants unfurled their leaves or the great continents began their slow, geological dance. Their very existence, their unique physiologies, their adaptations to extreme pressure, crushing cold, and absolute darkness, are testaments to evolutionary pathways forged over millions, even billions of years. When we study these organisms, we are not just observing novel life forms. We are peering through a biological window into epochs long past. The DNA of a deep-sea sponge can reveal genetic sequences that have remained remarkably unchanged for vast stretches of time, offering insights into the fundamental building blocks of life and the conditions under which life first arose. The fossilized remains found within the sediment layers of the abyssal plains, often preserved with astonishing fidelity due to the cold and lack of disturbance, tell stories of ancient ecosystems, of species that have long since vanished from the surface world, and of the slow, inexorable processes of extinction and adaptation. Consider the coelacanth, a fish once thought to be extinct for tens of millions of years, a living fossil that offers a direct glimpse into the anatomy of lobe-finned fishes from the Devonian period. Or think of the extremophiles found near hydrothermal vents. Their metabolic pathways, which harness chemical energy in the absence of sunlight, may well mirror the very first forms of life on Earth, life that thrived in a primordial soup, powered by the planet's internal heat. These deep-sea organisms are living laboratories, their forms and functions shaped by environmental pressures that have persisted or evolved over geological timescales. They carry within their genetic code, within their very cellular structures, the whispers of ancient oceans, of changing climates, of continental drift, and of the slow, patient work of evolution. By studying them, scientists can reconstruct past environments, understand the resilience of life, and gain a deeper appreciation for the long, unfolding narrative of our planet. The Midnight Zone, therefore, is not just a frontier of exploration. It is a library of life, with its oldest volumes bound in the flesh of its most ancient inhabitants. In the quiet depths, life's ancient echoes whisper of Earth's enduring story, a reminder that we are but a fleeting chapter in a saga written over eons. Human exploration is a recent, tentative step. Our understanding of the Midnight Zone, that vast, sunless realm stretching from 1,000 meters to over 11,000 meters deep, is remarkably nascent. For millennia, humanity has gazed at the stars, charting constellations and dreaming of other worlds, yet the depths of our own planet remained largely an enigma. It is only in the last century, and more intensely in the last few decades, that we have begun to truly breach the surface of this alien territory. Our initial forays were rudimentary, often limited by the immense pressures and crushing darkness. Early submersibles, though groundbreaking, offered fleeting glimpses, like a child peeking through a keyhole at a grand, hidden ball. These were not expeditions of comprehensive study, but rather brave, often perilous, attempts to simply survive the environment and bring back mere fragments of knowledge. The technology required to withstand the crushing embrace of thousands of pounds per square inch, to illuminate depths where no natural light has ever penetrated, and to sustain life in such an unforgiving habitat, is extraordinarily complex and prohibitively expensive. The sheer scale of the midnight zone is also a formidable barrier. It represents over 95% of the Earth's habitable volume, a space so immense that our current efforts feel akin to scooping water from the ocean with a thimble. Each mission, each deployment of a remotely operated vehicle, ROV, or a human-occupied submersible, is a triumph of engineering and human curiosity, but it covers only an infinitesimal fraction of this immense frontier. We are like explorers who have just landed on a new continent, having only mapped out a few small bays and inlets. The challenges extend beyond technology and scale. The extreme conditions can damage equipment, making recovery difficult and costly. Communication with deep-sea vehicles is slow and often unreliable, requiring patience and meticulous planning. Furthermore, the biological samples we can collect are often fragile, requiring immediate and specialized preservation to prevent them from degrading upon reaching the surface. The very act of bringing these organisms into our world with its different pressures, temperatures, and light can alter them, making their study even more complex. Yet, despite these profound difficulties, our tentative steps continue. Each dive, each sonar ping, each camera feed from the abyss adds another piece to an ever-growing, albeit still incomplete, puzzle. We are learning about new species, understanding unique adaptations, and beginning to map the topography of a world that was once entirely imagined. The history of deep-sea exploration is a testament to human perseverance, a narrative of overcoming seemingly insurmountable obstacles in pursuit of knowledge. From the bathyscaphs of the mid-20th century to the advanced, robotic explorers of today, our reach into the midnight zone has steadily extended, but it remains, in the grand cosmic scheme of things, a mere whisper in the vast silence of the deep. This exploration is not just about discovering new life forms. It's about understanding the fundamental limits of life itself and the incredible resilience that can emerge when conditions are pushed to their most extreme. The vastness of the unexplored deep serves as a humbling reminder of how much remains unknown, even on our own home planet, fostering a sense of wonder about the hidden corners of existence. Our tentative steps into the midnight zone reveal that our knowledge of this profound realm is as young as a single breath against the backdrop of eternal night. The vastness of the unknown still dominates. Even with our most sophisticated instruments, with our submersible probes capable of withstanding crushing pressures, and our advanced sonar that maps the contours of the ocean floor, the true extent of the midnight zone remains a profound mystery. We have only begun to scratch the surface, to glimpse the edges of a realm so immense, so alien, that it dwarfs our terrestrial understanding. Imagine, if you will, the sheer volume of water that exists below the reach of sunlight. It is a three-dimensional space that stretches for miles in every direction, a continuous, interconnected world that we have barely begun to chart. Our knowledge of the deep sea is, in many ways, akin to the understanding a single ant might have of the entire Amazon rainforest, a fleeting, limited perspective of an overwhelming immensity. The creatures we have discovered are but a fraction of those that likely exist. For every species catalogued, there are undoubtedly thousands, perhaps millions, yet to be identified, swimming in the eternal darkness, living lives we can only begin to hypothesize about. Their adaptations, their behaviors, their very existence are testaments to the boundless creativity of evolution, a creativity that flourishes in environments we would deem utterly inhospitable. The geological features of the midnight zone are equally enigmatic. We speak of abyssal plains, of trenches that plunge deeper than any mountain is high, of underwater mountain ranges and volcanic systems that spew life-giving chemicals into the frigid waters. Yet, the precise mapping of these features is far from complete. Vast swathes of the ocean floor remain unexamined, their secrets locked away by the sheer difficulty and expense of exploration. The currents that flow through these depths, the intricate chemical balances, the subtle shifts in temperature and salinity, these are all complex systems that we are only starting to comprehend. The midnight zone is not a static, unchanging environment. It is a dynamic, living system, constantly in flux, responding to forces both internal and external, many of which we are still struggling to identify. Our understanding of the life cycles of deep-sea organisms is also rudimentary. How do they find mates in such vastness? What are their reproductive strategies? How long do they live? These are questions that often have answers that are as surprising and unique as the creatures themselves. The discovery of new species in the deep sea is not an infrequent event. It is a regular occurrence, a constant reminder of how much we still do not know. Each expedition, each sample brought to the surface, reveals new forms of life, new ways of surviving, new chapters in the grand book of biology that are yet to be written. The midnight zone, in its overwhelming immensity and its persistent enigma, serves as a powerful reminder of the limits of our current knowledge. It is a vast, unexplored frontier, a testament to the fact that even in our age of advanced technology and rapid information, the universe and our own planet still hold an astonishing amount of the unknown. This sheer scale of what we do not know is not a cause for frustration, but for a deep and abiding sense of wonder, a quiet recognition that the universe is far grander and more mysterious than we can possibly imagine, and that there is always more to discover, always more to contemplate in the silent depths. The infinite darkness guards a universe of life, yet unseen, a silent testament to the boundless imagination of existence. We are just beginning to understand its rhythms. The deep ocean, this vast, unyielding expanse known as the midnight zone, operates on timescales and with a subtlety that has, for millennia, eluded our direct observation. Our understanding of its intricate workings is not a finished tapestry, but rather a collection of threads, painstakingly gathered and woven together by persistent scientific inquiry. We are like nascent astronomers, gazing at a distant galaxy for the first time, catching only glimpses of its grander, more complex dance. The rhythms we speak of are not the predictable ebb and flow of tides, nor the seasonal cycles familiar to terrestrial life. Instead, they are ancient, slow-moving pulses that govern the very existence of this alien world. Consider the subtle shifts in currents, imperceptible to human senses, that carry nutrients across vast distances, dictating the distribution and survival of entire communities. These currents are the arteries of the abyss, their flow a constant, silent narrative of exchange and sustenance. We are learning to read these currents, not with our eyes, but with sophisticated sensors and computational models, discerning patterns that reveal migration routes, feeding grounds, and the dispersal of larvae that will seed new frontiers in the darkness. Then there are the biological rhythms, far removed from the diurnal cycles that dominate our surface lives. Many deep-sea organisms exhibit life cycles dictated by the scarcity of food, by the long waits between encounters with prey, or by the monumental effort required for reproduction in such a dispersed environment. Reproduction itself can be a slow, deliberate affair, with some species taking years, even decades, to reach maturity and reproduce. The energy expenditure for these crucial events must be carefully managed, a testament to the profound efficiency demanded by life in the abyss. We are discovering that even the seemingly static communities around hydrothermal vents have their own dynamic cycles, influenced by the fluctuating geological activity and the availability of chemical energy. The very lifeblood of these oases, the chemosynthetic bacteria, wax and wane with the vent's activity, creating waves of abundance and scarcity that ripple through the entire ecosystem. Understanding these rhythms requires not just snapshots of data, but long-term, continuous observation, a commitment to patience that mirrors the very nature of the deep sea itself. Furthermore, we are just beginning to grasp the long-term geological and climatic influences that shape the midnight zone. Over millennia, shifts in global climate, changes in ocean circulation patterns, and even the slow, inexorable processes of plate tectonics have sculpted the abyssal plains, created trenches, and established the very topography that life has adapted to. The deep ocean acts as a massive buffer and regulator of global climate, absorbing vast amounts of heat and carbon dioxide. Its slow, deep currents play a crucial role in distributing these elements, influencing weather patterns and ocean chemistry on a planetary scale. Our understanding of these slow, grand rhythms is still rudimentary, akin to understanding a symphony by hearing only a few isolated notes. Yet each new piece of data, each carefully analyzed sample, each meticulously mapped trench, adds another layer to our comprehension, revealing a world far more interconnected and dynamic than we ever imagined. The true rhythm of the midnight zone is one of immense, patient resilience, a testament to life's enduring capacity to adapt and thrive in the face of seemingly insurmountable challenges, a rhythm that whispers profound truths about existence to those willing to listen. The slow, steady heartbeat of the abyss beats in harmony with a universe that often operates beyond our hurried perception, reminding us that true understanding unfolds with the patience of the deep itself. The midnight zone reminds us of our own limits. The sheer scale of the midnight zone, this vast, seemingly endless expanse of perpetual darkness, serves as a profound and humbling reminder of the boundaries of our own understanding and our physical limitations. Imagine, if you will, the immense pressure that would crush an unprotected human instantly, a force measured in atmospheres, stacking upon itself with every meter descended. Our bodies, so perfectly adapted to the gentle embrace of Earth's surface, are utterly incapable of withstanding such crushing weight. This is not a place for us to wander freely, but a realm that demands respect for its alien conditions. We can send our most advanced submersibles, marvels of engineering designed to withstand these extremes, but even these are mere specks, temporary visitors in a world that has existed for eons without our presence. The light we rely on, the very foundation of our sensory experience, is entirely absent here. Our eyes, evolved to interpret the spectrum of sunlight, are useless in this absolute blackness. We are forced to rely on the ingenuity of others, on the biological adaptations of creatures who have found ways to see, to communicate, and to thrive in ways we can barely comprehend. Consider the sheer distance, the immense journey required to reach these depths. It speaks to a world so removed from our daily lives, so alien in its environment, that it feels like venturing to another planet. Our curiosity drives us to explore, to push the boundaries of what is known, but the midnight zone acts as a stark and beautiful boundary. a testament to the fact that there are realms on our own planet that remain largely beyond our direct experience. It is a place that does not yield its secrets easily, a place that forces us to acknowledge the vastness of the unknown. This realization, this confrontation with limits, is not a cause for despair, but for a deeper appreciation of the extraordinary adaptations that life has achieved. It highlights the incredible diversity of existence and the myriad ways in which life can find a foothold, even in the most seemingly inhospitable conditions. The midnight zone, in its silent, crushing immensity, reminds us that we are but one small part of a much larger, more complex, and infinitely wondrous tapestry of life. It is a gentle nudge, a philosophical whisper from the deep, suggesting that our perspective is shaped by our environment, and that other environments foster entirely different realities. The very existence of such a realm, so different from our own, expands our concept of what is possible, even as it defines the edges of our own capabilities. In the crushing dark, our own fragility is illuminated, a quiet understanding of the vastness that lies beyond our direct touch. Its silence speaks volumes about resilience. The profound silence of the midnight zone is not an absence of sound, but rather a different kind of sonic landscape, one where life has learned to communicate and thrive without the cacophony of the sunlit world. This silence is a testament to an ancient, enduring resilience, forged over eons in an environment that would be utterly inhospitable to most surface dwellers. Imagine the immense pressure, a crushing embrace that would instantly obliterate delicate tissues, yet life here has evolved to not only withstand it but to utilize it. Consider the sheer scarcity of resources, the vast distances between sustenance, the constant struggle for survival. In the absence of visual cues that guide so much of life above, the creatures of the abyss have developed extraordinary sensory adaptations. They rely on vibrations, on subtle shifts in water pressure, on chemical trails that drift for miles in the inky blackness. Some creatures emit their own soft, internal lights, a silent language of bioluminescence, flashing signals that can mean anything from a mating call to a warning, or even a lure for unsuspecting prey. This is a communication system built not on shouting, but on whispers, on the most minute adjustments, on a deep, intrinsic understanding of the subtle forces that govern their world. The silence is the canvas upon which these delicate interactions are painted. It allows for an acute sensitivity to the slightest disturbance, a hyper-awareness that is crucial for survival. Think about the sheer tenacity required to exist in such a place. There are no gentle breezes, no warm sunlight to energize growth. Instead, there are slow, deliberate movements, energy conserved with every flicker of a fin, every pulse of a tentacle. The creatures here are masters of efficiency, their bodies perfectly adapted to a life of extreme conservation and patient waiting. They have learned to extract every possible nutrient from the sparse offerings that drift down from above or emanate from the rare volcanic vents. Their resilience is etched into their very being, in their slow metabolisms, in their ability to endure long periods of starvation, in their unyielding drive to simply be in a place that seems designed for non-existence. This silence, then, is not emptiness. It is a filled space, a vibrant, if understated, testament to the indomitable spirit of life, a profound quietude that speaks of an ancient, unwavering strength that has persisted against all odds, adapting and evolving in ways that continue to astound us. It is a quiet that carries the weight of millions of years of evolutionary triumph, a gentle hum of existence in the face of overwhelming pressure, a silent symphony of survival. In the enduring quiet of the deep, life's most remarkable strength is revealed not in bold declarations, but in the persistent, unyielding act of existence. This realm is a testament to life's ingenuity. The creatures that call the midnight zone home are not merely survivors. They are architects of existence, sculpting their forms and behaviors to thrive in conditions that would extinguish most life as we know it. Consider the sheer, unyielding pressure, a constant, crushing force that would flatten a human in an instant. Yet the organisms here have developed cellular structures and biochemical processes that not only withstand this immense pressure, but, in some cases, even utilize it. Their very essence is a defiance of our surface world understanding of what is possible. They have evolved without the guiding light of the sun, a fundamental force that shapes all life on our planet, and in doing so, have forged entirely new pathways of adaptation. Their metabolic rates are often incredibly slow, a strategy to conserve energy in a realm where food can be scarce and unpredictable. This slowness, however, is not a sign of weakness, but of profound efficiency. They have learned to extract every last bit of sustenance from their environment, whether it be the occasional bounty of marine snow drifting down from above, or the chemical riches of hydrothermal vents. Their sensory systems are a marvel. With sight often rendered useless, they have honed other senses to an extraordinary degree. The lateral line system in fish, for example, can detect the faintest vibrations in the water, allowing them to sense the movement of prey or predators from great distances. Some possess electroreception, the ability to sense the weak electrical fields generated by other living organisms, turning the dark water into a map of living energy. And then there is bioluminescence, a phenomenon that transforms the perpetual darkness into a canvas of living light. This is not merely for illumination. It is a complex language of communication, of attraction, of defense, and of predation. Species have developed intricate patterns of light, flashing in specific sequences to signal to potential mates, to startle attackers, or to lure unsuspecting prey into their waiting jaws. The anglerfish, with its dangling, luminescent lure, is perhaps the most iconic example, a living beacon in the abyss, a testament to the creative power of natural selection. The vampire squid, when threatened, can invert its cloak-like webbing, revealing rows of bioluminescent organs that flash and swirl, creating a dazzling, disorienting display that allows it to escape into the darkness. The very existence of complex ecosystems, such as those found around hydrothermal vents, is a profound demonstration of life's relentless drive. These vents spew superheated, mineral-rich water from the Earth's crust, creating oases of life in an otherwise barren landscape. Here, chemosynthetic bacteria form the base of the food web, deriving energy from chemical reactions rather than sunlight. Giant tube worms, clams, and mussels thrive in this extreme environment, their existence a direct consequence of life's ability to find and exploit novel energy sources. The diversity of forms and strategies is breathtaking. From the gelatinous transparency of some jellyfish, which makes them virtually invisible, to the hardened, armor-plated exteriors of certain crustaceans, each organism is a perfectly honed instrument for survival in its specific niche. Their ingenuity is not a conscious design, but a cumulative history of successful adaptations, a silent, slow-motion ballet of evolution that has created forms and functions far beyond our initial imaginings. This realm, in its profound darkness and immense pressure, is a living library of biological innovation, a constant reminder that life, in its most fundamental essence, is an act of boundless creativity. In the silent, unyielding depths, life has painted its most extraordinary masterpieces, proving that where light fails, ingenuity finds its way. The mysteries of the deep mirror, our inner worlds. The profound darkness of the midnight zone, a realm where sunlight has never penetrated, where pressures are immense and life adapts in ways that seem almost alien, holds a curious and deeply resonant connection to our own inner landscapes. Consider the vastness, the sheer, unyielding expanse of this deep ocean. It is a space that, much like our own unconscious mind, remains largely unexplored, a frontier of immense depth and potential. Within this darkness, life has not ceased to exist. Instead, it has transformed, finding new ways to thrive, to communicate, to simply be asterisk. This is a powerful metaphor for the human psyche. We too carry within us vast, uncharted territories, depths of thought, emotion, and experience that lie beyond the immediate reach of our conscious awareness. Just as the creatures of the abyss have evolved unique sensory organs to perceive their environment in the absence of light, we too possess intuitive senses, subconscious navigations, and emotional currents that guide us through the complexities of our own existence, often in ways we don't fully understand. The bioluminescence that flickers and dances in the blackness, a language of light in a world of shadow, can be seen as analogous to the fleeting insights, the sudden inspirations, the flashes of intuition that illuminate our own inner darkness. These are the moments when a forgotten memory surfaces, when a solution to a complex problem dawns, when a deep emotional truth reveals itself. Like the anglerfish luring its prey, our subconscious can draw us towards understanding, towards resolution, even when the path is not clearly lit. The resilience of life in the midnight zone, its ability to persist and flourish under conditions that would seem impossible to us, is a testament to the enduring strength of existence itself. This mirrors the incredible capacity of the human spirit to endure hardship, to find hope in despair, and to adapt to challenging circumstances. The quiet, persistent existence of these deep-sea organisms, their slow, deliberate movements, their patient waiting, can teach us about the value of stillness, of observation, and of allowing processes to unfold in their own time. The pressure that shapes the deep sea, compressing and molding its inhabitants, can be seen as a parallel to the pressures of life, the stresses, the challenges, the societal expectations that shape our own characters and experiences. Yet, just as the creatures of the deep are not crushed by this pressure, but rather adapted to it, we too can learn to navigate and even be strengthened by the pressures we face. The sheer isolation of the midnight zone, its profound solitude, can also reflect moments of introspection, of necessary withdrawal from the external world to connect with our inner selves. In this solitude, we can often find clarity, a deeper understanding of our own needs and desires, much like a solitary explorer charting unknown depths. The ancient nature of the deep-sea environment, its stability and continuity over millennia, offers a sense of perspective, reminding us of the long arc of time and our place within it. This can be profoundly soothing, diminishing the perceived urgency of our immediate concerns and fostering a sense of peace. The midnight zone, in its silent grandeur and its extraordinary adaptations, serves as a mirror, reflecting back to us the hidden depths of our own being, the resilience of our spirit, and the universal drive of life to persist and find meaning, even in the most challenging of circumstances. As the deep sea holds its mysteries within its silent, pressure-filled embrace, so too do our own inner worlds harbor profound truths, waiting to be discovered in the quiet stillness. The ocean's depths offer a profound calm. This vast, unyielding realm, stretching from the twilight zone's fading light into the absolute blackness of the abyssal plains and the crushing pressures of the Hadal trenches, is a testament to a different kind of existence, one far removed from the frenetic pace of the surface world. Here, where sunlight has never penetrated, life has evolved not through competition for light, but through adaptation to an environment of perpetual darkness, immense pressure, and scarce resources. The sheer scale of this environment is almost incomprehensible. Imagine a volume of water so immense that the surface, with its waves and winds and bustling activity, becomes an irrelevant memory. The pressure at the deepest points can exceed 1,000 times that at sea level, a force that would instantly obliterate anything not specifically adapted to withstand it. Yet, life persists, in forms that are both alien and astonishingly beautiful. The creatures of the Midnight Zone have developed intricate strategies for survival. Many rely on bioluminescence, not just for communication or hunting, but as a fundamental aspect of their being, a living light in the eternal night. Others have evolved specialized sensory organs that can detect the slightest vibrations or chemical traces in the water, navigating their world through senses that we can only dimly imagine. The concept of struggle for existence takes on a new meaning here. It's not a frantic scramble, but a patient, enduring persistence. Food is often scarce, falling from the surface in a slow, steady rain of organic matter known as marine snow. Organisms here have evolved incredibly slow metabolisms, capable of surviving for long periods between meals. Their movements are deliberate, their lives measured in a different temporal scale. This slow, deliberate existence, this profound adaptation to stillness and pressure, creates an aura of deep, unwavering calm. It is a world that exists outside of our everyday concerns, a place where the anxieties of the surface simply cannot penetrate. The sheer, unrelenting nature of the deep sea is, in its own way, a source of peace. It is a realm that demands nothing of us, a silent observer of the eons, a testament to the enduring power of life in its most resilient forms. The absence of light, the overwhelming pressure, the scarcity of food, these are not limitations, but the very conditions that have forged an extraordinary and serene ecosystem. It is a place where the fundamental forces of nature operate without interruption, and where life, in its most patient and determined guise, finds a way to not just survive, but to flourish in its own unique, quiet majesty. The profound calm of the ocean's depths is a reflection of its immense power and resilience, a silent, enduring presence that reminds us of the vastness of the universe and our place within it. It is a stillness that seeps into the soul, a quietude that washes over the mind, inviting a deeper sense of peace. The deep ocean, in its silent, dark embrace, offers a profound and enduring calm, a stillness that mirrors the deepest quietude within ourselves. Our calm exploration has covered the profound depths of the Midnight Zone, a realm where sunlight never reaches, yet life flourishes in astonishing ways. We have journeyed through the crushing pressures, the alien adaptations, and the silent language of bioluminescence, discovering that this seemingly desolate expanse is, in fact, a vibrant tapestry of existence. We have reviewed the principles of life thriving in extremes, the ingenious solutions evolved by creatures in perpetual darkness, and the sheer, majestic resilience of the natural world. Tonight, we have been reminded that even in the absence of light, there is a profound and intricate beauty, a testament to the enduring power of life. This vast, unexplored frontier, stretching far below the familiar surface, offers a powerful perspective on our own place in the grand cosmic order. Just as these deep-sea organisms find their way and thrive in conditions we can barely imagine, so too can we navigate the challenges of our own existence with a sense of quiet wonder and enduring strength. The mysteries of the deep mirror the vast, often unseen landscapes within ourselves, reminding us of our capacity for adaptation, our inherent resilience, and the quiet, persistent pulse of life that connects us all, from the deepest ocean trench to the furthest star. It is time to rest now. Allow the vastness of the midnight zone to lull you into a deep, peaceful sleep. Let the quiet wonder of its inhabitants, their silent dances in the dark, and the profound peace of the abyss wash over you, carrying away all your worries and anxieties. Sleep well. Good night. If you happen to still be awake, you can drift into the next chapter now, continuing your journey into the quiet wonders of the universe.